Okay, good morning students. So let us continue with the next lecture on trigonometric identities. I hope you have revised what we had discussed in the previous lecture, because slowly now we are going to move towards some complex problems. Okay, problems, as you have already learned, most of them in this particular chapter will be related to the proving aspect. Okay, you will be given some left hand side and you will be having to prove it to some right hand side. Okay, so let us start. We'll solve some 4-5 odd questions in this second lecture also, and after that we'll be giving you some assignment to do, okay, based on what we have discussed in the first two lectures. Okay, so let us start with the first question of today's lecture. Under root 1 plus cos a upon 1 minus cos a, so this entire thing is in the under root sign, okay, is equal to, so you have to prove it to be equal to, see, I am not writing to prove, it is understood that you have to prove this side is equal to the right hand side. Okay, so the right hand side is cosec a plus cot a. Okay, so as always we will start with the left hand side first. Okay, so in questions like these, what is important is that if you note, you have in the under root sign, you have 1 plus cos a divided by 1 minus cos a. So whenever you have questions like these, what you will do is you will multiply the entire thing which is there in the under root sign with the exact same thing which is there in the denominator, but with a change in the middle sign. Okay, so if it is like 1 minus cos a here, you will multiply both the numerator, you will multiply this entire thing with 1 plus cos a both in the numerator as well as in the denominator. Now why we are exactly doing this is something that you will get to know in the next step. Okay, now you see, please note, had this question been 1 minus cos a upon 1 plus cos a, then you would have multiplied by 1 minus cos a, 1 minus cos a. Okay, so essentially what you have to do is you have to multiply with a change in sign. Okay, so if it is 1 minus cos a in the denominator here in the original question, then you will multiply by 1 plus cos a both in the numerator as well as in the denominator. So essentially what we are doing is we are not making any change. See, 1 plus cos a upon 1 plus cos a, essentially it gets cancelled out. So you have your question over here. Okay, now the purpose of doing this can be seen in the next step when you will see 1 plus cos a and 1 plus cos a, the same thing is there, so you get 1 plus cos a square in the numerator. Similarly in the denominator, if you see, now this is of the form a minus b into a plus b. So you remember that identity, a minus b into a plus b gives you a square minus b square. Okay, so using that we can write 1 minus cos square a here. Okay, which will in the next step it will become, if you see, you can simply have 1 plus cos a square will remain like this upon 1 minus cos square a can be written as sine square a. Why? Which identity have I used in the denominator portion? Obviously I have used sine square theta plus cos square theta equal to 1. If you remember in the previous lecture, in the start of the lecture I had discussed this. So therefore when you take cos square theta to the right hand side, you will be left with 1 minus cos square theta on the right side, and you will have sine square theta left on the left hand side. So in place of this entire thing which is there on the right side, I can put sine square theta. Let it be, the angle can be theta, it can be a whatever. Okay, so now if you see, there is a square sign here and there is an under root. So essentially from the numerator you get 1 plus cos a, and from the denominator you simply get sine a, because under root is power half and there is already a square. Okay, so now you see, as I have always been maintaining, that you have to have a look on the right hand side also. What are you essentially going to be proving? So you have to have cosec and cot on the right hand side. So if you see, observe this carefully, 1 upon sine A can be written as cosec A plus cos A upon sine A is simply nothing but cot A. So in hardly 4 steps you get cosec A plus cot A, which is equal to your right hand side. Therefore your question has been proved. Okay, so please remember now, particularly from today's lecture onwards, we will be dealing with different types of questions, some of which will have particular ways of doing them. Okay, while most of the questions can be done in a number of different ways, but we will try to keep in mind the simplest possible ways of solving the problems. Okay, so whenever you see under root sign on the left hand side, and there are things like 1 minus cos A, 1 plus cos A, 1 minus sin A, 1 plus tan A, then you will have to multiply both the numerator as well as the denominator by the conjugate. So conjugate, basically it means you have to multiply the numerator and as well as the denominator after changing the sign of the middle sign of the denominator here. Okay, so that was the first question. Now let us move to the second question. Okay, so here's your second question for the day. Tan theta plus sin theta upon tan theta minus sin theta is equal to sec theta plus 1 upon sec theta minus 1. Again, I am not writing to prove. It is understood that you have to prove. These are all proving questions. So left hand side has to be proved equal to the right hand side. So usually, like we always start, we will start with the left hand side. Now you see, this tan theta can be written as sin theta upon cos theta, and plus sin theta you have over here. Then there is, that part is the numerator part. Similarly, the denominator, if you write, you can simply write sin theta upon cos theta, because again it is tan theta here, minus sin theta. So that is the first step that you will do. Now after this, it will depend upon your the way in which you remain alert as to what is there on the right hand side. Now you see, right hand side has sec theta. The only trigonometric ratio present on the right hand side is sec theta, and as of now we don't have anything like sec theta here. Here means in the left hand side that we have started with the simplification of the left hand side. Right now we do not have any sec theta present here, whereas we have to ultimately get sec theta because our right hand side has only sec theta present in it. So the moment you realize this, immediately your mind should go to bringing sec theta somehow in the left hand side. So what is sec theta? Let me remind you, sec theta is nothing but the reciprocal of cos theta. So as long as you remember this, you can easily see that this 1 upon cos theta, because this cos theta is in the denominator, so if I keep sin theta separately, what I am telling you is this, sin theta into 1 upon cos theta. This portion can be written like this, plus obviously this sin theta will remain over here, upon, similarly this also can be written as sin theta multiplied by 1 upon cos theta, and this time, as you can see, there is a minus and sin theta here. Reason why I am writing it like this is, now you can easily write this 1 upon cos theta, 1 upon cos theta as sec theta. So in the next step, you will simply have sin theta into sec theta plus this sin theta upon, similarly in the denominator you have sin theta separately, and 1 upon cos can be written as sec theta. Here there is a minus sin theta. Your question is more than 90% solved. because now if you have a little bit of presence of mind, you can simply see that in both the terms of the numerator you have one sign present. Sign here also, sign here also. Similarly, in the denominator you have sign in this term also, you have sign in this term also, and you do not need any sign theta in the right hand side. So you can simply take out common sin theta from the numerator, so this will become sec theta plus 1. Similarly, you can take out sin theta from the denominator also common, so this will become sec theta minus 1. Okay, this sin theta and this sin theta gets cancelled, so what you are left with in the end is nothing but what you have to prove. Okay, so sec theta plus 1 upon sec theta minus 1. As you can see, this is exactly matching with what you have on the right hand side. Okay, so what did we learn in this particular type of a question? What we learned was that we always have to have a look, or we always have to keep the right hand side image in the mind. We must always remember what has to be brought, which trigonometric ratio has to be brought on the right hand side. So we had sec theta here, therefore we will try to simplify the left hand side so as to bring sec theta without changing anything in the original question. So you can simply start practicing like this. Okay, so now let us move on to the third question. Okay, so here's the third question that we will do in today's lecture. We have, as you can see on the left hand side, you have three different brackets. Okay, all these bracketed portions are getting multiplied with each other. So the left hand side is quite complex, as you can see, whereas what you have to prove this left hand side equal to is simply 1. Okay, so on the right hand side you have 1. That means after simplifying this entire left hand side, you should get nothing but 1. Okay, so let us start with the left hand side, because there is nothing to do on the right hand side. Most of the things are to be simplified from the left hand side. Okay, so we will start with the first bracket. Tan theta, as usual, can be written as sin theta upon cos theta, plus cot theta. As you know, it is just the reverse of tan theta, so it will be cos theta upon sin theta. So that is your first bracket. Similarly, in the second bracket, cosec, as you know, is reciprocal of sine. Okay, so what I'll do is I'll simply write this as A. All the angles have to be written same, so I'll simply write A everywhere. Okay, you can also use theta, but in that case there will be, all the angles will be theta. Okay, so you see, tan A has been written as sin A upon cos A, cot A has been written as cos A upon sin A. Similarly, cosec A will be 1 upon sin A. Now sin obviously is the simplest of the forms, so nothing to change here. The last bracket that you can see, sec is 1 upon cos. Okay, so this is what I will write. Okay, so this is the first simplification that you will do. Now if you have a look at the next step, what we can do is, in this first bracket, if you take the LCM, you will have sin A cos A as the LCM. Okay, so now when you read the table, cos A one's a cos A, so sin A remains. Sin A into sin A will give you sin square A plus. Now there is a plus sign, so I'll write plus. Sin A, you read the table of sin A, sin A one's a sin A, so cos A is remaining. Cos A into cos A will become cos square A. Okay, the moment you get sin square A plus cos square A, you know that sin square theta plus cos square theta is 1, or sin square A plus cos square A is 1. So in the next step, the entire numerator portion will become 1. Okay, but as of now, let us move on to the second bracket. Obviously, in the second bracket also, when you take the LCM, you will get the LCM as sin A, because there is nothing here. You can simply put upon 1 here, you can simply put upon 1 here. So in the second bracket, sine A is there, you have 1 minus sine square A. Okay. How? You can read the table. 1 into sine A is sine A, so sine A into sine A is sine square A. Similarly, in the third bracket, when you take the LCM will be cos A, so this will become 1 minus cos square A. Okay, so this is what you have in the 3 different brackets. Now moving on to the next part. Now this complex looking thing will start getting simplified. Sine square A plus cos square A is simply 1. So I'll write 1 and I'll leave the denominator portion as sine A cos A. Okay, into. So that is the first bracket multiplied by, now you see 1 minus sine square A can be written as cos square A. Okay, again I have used the identity. Which identity? Sine square theta plus cos square theta equal to 1. Therefore cos square theta will be 1 minus sine square theta. Okay, upon sine A, this is the second bracket multiplied by, what is the third bracket? 1 minus cos square A can be written as sine square A. Okay, and obviously there is cos A here. Now it is all solved. As you can see, there are 2 signs present in the denominator, there are 2 signs in the numerator. Similarly, there is cos A into cos A in the denominator, and you have cos square A in the numerator also. So this cos square A gets cancelled with cos and cos. Similarly, these 2 signs can be cancelled simply with these 2 signs in the. So essentially what you have is equal to 1, which is equal to your right hand side. Okay, so questions like these, although you can solve it in some other ways also, but then I suppose this is one of the easiest ways of solving it. Okay, so this was your third question. I hope you are keeping a track of the way in which we are solving. Okay, now we will move on to the remaining 2 questions for this lecture. Okay, so let us begin with question number 4. Cos A upon 1 minus tan A plus sine square A upon sine A minus cos A. This is equal to cos A plus sine A. You have to prove that this entire left hand side is equal to what we have on the right hand side. Okay, so the first thing that you notice is most of the trigonometric ratios are basically in the simple forms, that is sine A and cos A. On the right hand side you only have sine A and cos A. So let us once again start with the left hand side. On the left hand side, as you can see, we have cos A upon 1 minus, this tan A can be written as sine A upon cos A. Okay, similarly on the right hand side, as you can see, there is nothing to be changed. You have the simplest of the ratios. We have sine square A upon sine A minus cos A. Okay, the reason why I have changed this tan into sine and cos is because you see all the remaining ratios are already in sine and cos. Even the right hand side has to be simply sine and cos. Okay, so the only change that we had to make was this tan A has to be represented as sine A upon cos A. Okay, now you see in the next step you will have cos A upon, now if you see, this can be written as 1 upon 1. So when you take the LCM, you will have in the denominator you will have cos A. So 1 into cos A is cos A, so you will have cos A minus sine A in the denominator. Okay, so essentially what I have done in this portion here is I have taken the LCM for this particular denominator. So you have cos A and then cos A minus sine A, plus again you don't have to do anything over here as of now, sine square A upon sine A minus cos A will remain like this. Now this cos A obviously will go to the numerator, main numerator. Why? Because this is in the denominator of the denominator, this entire thing. So this cos A goes above, and there is already a cos A present, so you will have cos square A in the numerator, and you will be left with only this portion, which is cos A minus sin A in the denominator, okay, plus sin square A upon, now you see, what is the denominator here? The denominator on the left hand side is cos A minus sin A, whereas here it is sin A minus cos A. So if I want to make this denominator and this denominator, both these denominators, if I want to make them same, what will I do is I'll have to change the signs of this. Sin A has to be with a minus sign, cos A has to be with a plus sign, whereas here it is just the opposite. So what I will do is I will take out a minus sign common. So when I take out the minus sign common, this central sign will become minus, and now I can write down cos A minus sin A. Did you understand what I did? Reason why I am taking minus sign common from here is so that I get the same denominators, which will ensure that in the next step I can take down a simple LCM, okay, because both the signs of these sin A and cos A, they were different. Here cos A was with plus, here cos A was with minus, here sin A was with minus, here sin A had a plus sign. So I took out minus common from this, making this minus, and therefore this has changed. Now easily I can, if I want to take the LCM of this portion, both are the same thing, so I can simply write down cos A minus sin A as the LCM. Okay, so cos A minus sin A, cos A minus sin A will give you an LCM of cos A minus sin A. So now when you read the table, you will simply get cos square A here minus sin square A here. Okay, so in the next step, all these are okay. So in the next step, now you keep in mind what is there on the right hand side. On the right hand side you have cos A plus sin A. Now you see, have a look at this portion, this numerator portion. Is it not in the form A square minus B square? Yes, A square minus B square, which can be written as A plus B into A minus B. Okay, so using this identity that we learnt in algebra, what we will do is, you see, this portion can be written as A plus B into A minus B. Now why and in what way is this expansion useful? You can easily have a look at what is present in the denominator. What is present in the denominator is exactly this portion. So this entire bracket gets cancelled with this entire bracket, thereby leaving only cos A plus sin A in the numerator. And you can see that we are simply left with, as you can see, let me write it down over here, what is left is this cos A plus sin A. Okay, this is the only thing present, and you can see it is equal to the right hand side. Okay, so we had to prove, what we had to prove has been arrived at. Okay, so this is the way, the different ways in which you can go ahead and solve these problems. Now let us move on quickly to the last question for this lecture, which is question number 5. Okay, so here is our last question. Apparently again it appears to be a difficult question with by the first looks, but then you do not have to get worried or anxious just by looking at the question. Okay, now we are well equipped to with the different identities that we have and the different ways of solving questions. So we will not get nervous just by looking at the question. We will start like we always start, with the left hand side. Again, you have to keep all the identities in mind. If you remember, I had given you an identity, sec square theta is equal to 1 plus tan square theta. Okay, or simply you can, if you want, you can put it in terms of angle A. Sec square A is equal to 1 plus tan square A. Similarly, I had also given you cosec square A is equal to 1 plus cot square A. If you have these two identities in mind, immediately you will find that this first bracket is this, the second bracket is this bracket. So what you can do is, immediately while starting the left hand side, you can say this first bracket can be written as sec square A, plus this second bracket can be written as cosec square A. Okay. Now the reason why I wrote these identities was just for a small revision. So I hope you remember this. Now I'm going to delete this. So by using those two identities, my left hand side entire portion has become this. Okay. Now keep in mind what is there on the right hand side. What is there on the right hand side is simply sine. Okay. It is simply sine. So this portion can easily be written as this, because we know cosec is the reverse reciprocal of sine. Therefore cosec square A can be written as 1 upon sine square A. So as far as this portion is concerned, we have changed it in terms of sine. What about this? Now if you see, this can also be written as sec is reciprocal of cos. So I can write down sec square A is equal to 1 upon cos square A. Obviously right now we don't need cos in the right hand side, so we will have to get rid of this cos square. Okay, so in the next step what I can do is, I can, if I want, I can take the LCM. So this will become sine square A cos square A. Okay, cos square A, sine square A. So the LCM will be sine square A cos square A. Now read the table. Cos square A, 1's a cos square A. So what we are left with is sine square A. Sine square A into 1 will give you sine square A, plus, read the table of sine square A. Sine square A, 1's a sine square A. So we are left with cos square A. Cos square A into 1 is cos square A. Sine square A plus cos square A is nothing but 1. So in the next step you simply have a big 1 at the in the numerator, and what you are left with in the denominator is sine square A into cos square A. Now very simply put, we have already got a 1 which we had to get according to the right hand side. See, the right hand side has 1 in the numerator. We have already got a 1, so we have to do nothing more in the numerator. Whereas in the denominator, you see, sine square A is okay, but cos square A need not be there. So sine square A I will keep like that. Cos square A I will represent it in terms of 1 minus sine square A. Again, the identity that I have used is sine square A plus cos square A. We know it is 1. Therefore, cos square A can be written as, this sine square A will be taken to the right hand side. So I can write, in place of cos square A, I can write 1 minus sine square A. Now you will realize the reason why I have done this conversion is because now I only have sine present everywhere. We only need sine. So now one last step is remaining. In the last step, this sine square A goes inside. So you have sine square A into 1, which will give you sine square A itself, minus sine square A into sine square A will make it sine to the power 4A. This entire thing is what you had to prove. So this is equal to your right hand side, as you can see. Okay, so these were some of the more complex questions of exercise A, 22A. So I hope now you will be able to solve most of the questions. After this lecture, once you go through this lecture properly and you practice a few questions on your own, we are going to give you the first assignment for this chapter. I hope you will be doing it on your own and after you have practiced. Okay, thank you students. Have a good day.